Hey guys, welcome to my YouTube channel. I want to discuss the topic of ionic equations here. We are going to discuss two types of equations, total ionic and net ionic equations. In this video, I'm going to go about precipitation reactions, where we have two ions joining in a solution, in an aqueous solution, to form a solid precipitate, okay? And we're going to write down total ionic equation and net ionic equation. Remember, ions, we should know them something like this, which is a phosphate ion, and we should know not only their formula, like phosphorus and 4 oxygen, so it's a PO4, but also the charge, which is triple E minus. So phosphate, something like this, we should know about both the formula and the charge, or something like this, ammonium, that is NH4 and the charge is +1, so NH4 plus. Okay, or the two very important ions, the hydroxide OH minus, so that's the OH, the formula, and then the charge is -1, or the proton itself, okay, the H plus. So we should know both the formula for ions and also their charges. Okay, so I'm going to discuss equations and letting you know how do we write down a total ionic equation, and that's to dissociate whatever is dissociable in an ionic equation. Okay, let's start with the first example and then move on to other examples as we go. My first example is a reaction of lead nitrate, Pb NO3 K2S, giving you 2KNO3, or potassium nitrate, plus PbS, which is a precipitate. So this sign means it's a precipitate, or it's possible that I gave you aqueous, and this one as a solid. Okay, just for simplicity and just for because I'm moving fast in this, instead of putting the aqueous, I just do designate the precipitate one in these reactions with a going down arrow. That means that one is the solid one that you're not going to dissociate. Okay, I'm not going to rewrite every time the aqueous signs and the solid ones, because it's going to take a lot of time. So first thing that we want to do is to actually write down any ionic species in each side for the compounds that are dissociable. This one is dissociable. There's a Pb plus something, I don't know what plus, but I can judge from the charge of these nitrates. Okay, so nitrate is NO3 minus. Okay, and then if I have two of them, it means double negative, and I should have a double positive for my phosphorus. Okay, it's for my lead. Okay, so the charge for Pb is going to be Pb double plus, and then K plus, and then S double minus, because again you have 2K and K is +1. Again, how do you know the charge for something like K? K is a main element, so you should be able to go to the groups in your periodic table and figure out that, okay, that's my potassium here, it's in group 1 and the charge should be +1. Okay, so that's that, and then I move on to the next side. It's again K plus and NO3 minus, and the PbS I'm not going to actually be able to dissociate. Now if I only work out the coefficients for these, the numbers of these ions, that's my total ionic equation. Okay, and when you do it on a test or something like that, you should actually put aqueous. I'm not doing that because I want to move fast and I want to do as many examples as I could in this one video. So one lead, or one Pb double plus, 2 nitrate, because again polyionic anions or cations are going to be engaged in parentheses if they're a number other than 1. So that's 2 nitrate. Also here you have 2 potassium and 1 S2 minus. Also here you have 2 Ks and 2 nitrates as well. The 2 applies to both of those. And Pb and 1S. So actually that one is not dissociable. And this is called the total ionic equation. The net ionic equation then is to actually see what kind of ions do we have the same in both the product and the reactant side. So that's, I'm going to circle them, the two potassium ions and the two nitrate ions, okay? And the rest of those, like whatever remains, I'm going to rewrite the equation with whatever remains, those that are not circled, and that gives me the net ionic equation. Okay, I as well do aqueous solid. I'm going to tell this, but I'm not going to write that because it's going to take more and more time. Let's move on to yet another example. See how many examples could I possibly cover in this one video here for you. Barium iodide, sodium sulfate, giving you barium sulfate, and which is the precipitate, and 2 sodium iodide. Okay, so that's another example. Let's then go talk about the ions first. Again, we have barium. Barium is a main group element. It's in group 2, and group 2 elements are going to be +2. Remember, +1, +2. Group 3 elements, only aluminum is the one that you're going to mostly see, or 99% of the time, and that's aluminum 3+. Carbon and group 4s, you're not going to see them. And then actually group 5, it's 3-, 2-, 1-. Okay, so that's how you judge the charges of main group, main element ions. Okay, so barium double plus and I-, again group 7 iodine, and then sodium plus group 1. Sulfate is someone that you should know. Barium sulfate, we're not going to dissociate because we're not allowed to. Again, sodium plus and I-. Now I go about the numbers. 1 barium, 2 iodine, 2 sodium, because Na2. Sulfate, there's just only 1. This one has 2 sodium, 2 iodine. Okay, the one that are common on both sides, remember, not only the identity of the ions should be the same, but also the coefficient should be the same. If you have 2 iodine and 2 I- on one side and 4 I- or 3 I- on the other, make sure to revise what you do, because you might have done something wrong. So sodium, these are the spectators. Now let's talk about the net ionic. Net ionic would be barium double plus and SO4 double minus, and it gives you barium sulfate as the precipitate. Again, aqueous, and solid, because that's the precipitate. Again, I'm going to tell you, but I'm not going to write. In this one on the top, all of these are going to be aqueous, and means it's going to be dissolved in water. This one is going to be a solid. Okay, so that's that. Let's go to yet another example. See if I could cover as much examples as I could in this single video. Again, Na2SO4, calcium iodide, gives you calcium sulfate. It goes down as the precipitate. Did we just do this? I think we just... No, we didn't. Okay, let me just focus here on 2NaI. It's very similar, but it's not the same thing. Okay, so I'll just cover this. Let me just mark this here. So let's go to the... Here again, we have sodium plus, we have sulfate, we have calcium is a group 2 element, so calcium double plus. I is group 7, so I minus. Calcium SO4 or sulfate is our precipitate, Na plus and I minus. Again, you have 2 sodiums, 1 sulfate, 1 calcium, 2 iodine, 2 sodiums and 2 iodine. Okay, if I'm going to designate the common ions, this we call the spectators. It means they're just watching the game, they're not doing anything. And the net equation is what actually happens. Calcium double plus joins... Oh, let me just do anytime you do ions, don't forget to do the charges. If you do SO4, that would be wrong. I'll cross it wrong. Okay, so SO4 double minus and then calcium sulfate. Now the ionic compound certainly must be neutral. That's why we have these underscripts there that makes them neutral. Okay, so that's this, and you're going to do this. Let's move on to yet another example to see what we can do there with yet another example. Okay, so let's go on and do this example of Hg2NO3 2 plus NaCl, two of them, giving you Hg2Cl2 as your precipitate and NaNO3, sodium nitrate, two of it. Let's just get rid of this, make this Cl a little smaller so I could actually, okay, that's that. So that's this reaction, and let's just dissociate all of this. This is your precipitate, so that's the one that I'm not allowed. So aqueous, and solid aqueous. This would be given, but I'm not just writing it because I want to move fast. So Hg2 double plus, this you have to memorize. And how do you know the charge is plus 2? Because of the 2 nitrate. Okay, and Hg2 is going to actually attach together, because that's the nature of the mercurose cation, and you have to know this. That's one of the very few examples. There are only 2 cations that are polyatomic. One is this, and the other one is NH4 or ammonium, which we just have, you happen to have the structure for the model for. Okay, so that's the only 2 polyatomic cations. NO3 is the familiar nitrate, sodium plus group 1, it's Cl minus group 7, Hg2Cl2 is our precipitate, and Na plus again, and NO3 minus again. Okay, so you have 2 nitrates here, just one of those Hg2s, 2 sodiums, 2 chlorines, also 2 sodiums, 2 nitrate here. Okay, and when you actually circle nitrates and circle the sodiums, you could see what's happening in this example for HgCl2. So that's Hg2 double plus and 2 Cl minuses, giving you Hg2Cl2 as your precipitate that's going down. Okay, so that's this. Let's move on to yet another example that I'm going to introduce. This is the last one that I write down, is net ionic equation. Let's move on to this. Magnesium nitrate, three sodium, my bad, 2 sodium phosphate, 6 sodium nitrate, and magnesium phosphate. And magnesium phosphate, the Mg3PO42 is the one that's going to precipitate. Okay, so magnesium is group 2, Mg double plus, and nitrate, sodium phosphate, PO4 triple minus, which we also happen to have the model for, and giving you sodium nitrate and the Mg3PO42, which is your precipitate that goes down. So 1 magnesium, 2 nitrates, 2 times 3, 6 sodiums, sodium cation, and 2 phosphate. Okay, here also you have 6 sodium and 6 nitrate. My bad, here also 3 times here. Let's see, do we have, oh, here I have a 3 that I'm missing, so 3 magnesium and then 3 times 2, 6 nitrate. Sorry, I just corrected the first equation. Okay, so that's it. So now let's go on and circle those common or spectator ions, the 6 nitrate, and you have also 6 sodium on both sides. So I could go on and say 3 Mg double plus and 2 PO4 triple minus, giving me magnesium 3 PO4 2 going down. That's the net ionic equation. Okay, so that's this. Let's move on to the next example. Okay, and that's example of AgClO4 plus Na2ClO4 giving you Ag2ClO4 as your precipitate, and also NaClO4, 2 of it. Okay, let's just see, this is sodium, oops, I apologize, sodium ClO4. Okay, perchlorate. So silver perchlorate is just ClO4 minus, we should know that, and this guy should be Ag plus. Okay, so we go on, Na plus, ClO4. This is not one of those onions, polyatomic onions that we know, but we could just discharge because there are 2 sodiums. This guy should be double minus, and there is Ag2ClO4. It goes down again, Na plus and ClO4 minus. Okay, now let's look at the numbers. There's just one of these 2 sodiums and one of that. Also here 2 sodiums and 2 ClO4s. I believe my Ag should have been 2, so you're gonna have 2 of this and 2 of this as well. My bad, I apologize again for the first coefficient that I missed. So you have 2 ClO4 and 2 sodiums on both sides, and you could say 2 Ag plus and ClO4 double minus, giving you the precipitate Ag2ClO4 as your precipitate. That's the net ionic equation. Okay, let's do one more example. If I could start writing it a bit easier and take these beakers to a higher position. Let's go on to my other example, that is Cr2SO4 3 plus 3 NH4 2CO3, giving me Cr2 CO3 3, that's going down, and then NH4 2SO4 and 3 of this. Okay, so that's the equation. I have 2 chromium. How can I judge the charge? Where you could look at the endice here and say my chromium is 3 plus, or you could say sulfate is double minus. 3 of those would make minus 6, and 2 of X should actually makes a plus 6, so X gonna be chromium, X gonna be 3 plus. Okay, so that's how you're going to judge it. Okay, or simply you could just swap the indices and find out. Sulfate, NH4 plus, which is well known, we should know. Carbonate, giving you chromium carbonate, and 3 times 2, 6. Oh, my bad. Let's just do the on. My best suggestion for you is to do the ions first to make sure you got the correct numbering, like the underscripts and the charges for the ions. Then you go again and revise the numbers. So 2 chromium, 3 sulfates, 3 times 2, 6 ammonium, and 3 carbonates Here also 3 times 2, 6 ammonium and 3 sulfates. Okay, so the 3 sulfates on both sides and the 6 ammonium on both sides are going to be your spectators, and if I just put down the remaining, that will give me my net ionic equation. Okay, so that's going to be your net ionic. 3 carbonates, 2 chromium triple plus or 2 chromic ions, and then Cr2 like chromic carbonate is your precipitate. Okay, let's do my final example here before I wrap up this video, and that's going to be my final example here, and that's NH4 2CO3 plus calcium chloride, giving me calcium carbonate, which is my precipitate. That's a C. Okay, and this is also calcium. And 2 NH4Cl. Okay, that's ammonium chloride. So NH4 plus, CO3 double minus, calcium double plus, and Cl minus, a sign between them, the plus sign between them. Here, calcium carbonate going down, NH4 plus and Cl minus. I didn't have enough space, but I put that right below, but you should have it in a line. Okay, now let's look at the numbers. 2 of those, 1 carbonate, 1 calcium, 2 chloride. Here you have 2 of ammonium and 2 chloride as well. So the 2 chloride anions and the 2 ammonium anions are the ones that are your spectators. Happen both at the reactant and the product side. If we ignore them, we could actually write down the net ionic equation. That's how you write that down. Calcium carbonate going down. Again, that's solid. This is aqueous, this is aqueous, and because this is my last example, I'm just going to literally do this real quick, and that's this. And this is the format that you need to actually write it down. Thank you for watching this video. We will have another video, and as I will go through more multiple examples of these ionic equations, but that would be for acid and bases. Let's wrap it up for this video right now.